Assalamualaikum and hi, I'm Aina Sahira. We're going to present about enhancing cybersecurity in Linux system to protect corporate data against malicious attack. So let's move to introduction part. In introduction, I have stated some important things such as problem, what it mirrors, objective and goals. So first of all, the problem. First, organization face increasing risk to sensitive client data. Second, a government-linked company, aka GLC, experienced a data breach due to a phishing email leading to virus infiltration and compromised customer banking details sold on the dark web. Next, what it matters. First, even secure system like Linux can be compromised without proper practice. Second, human error such as failing to detect malicious emails is a key factor in cyber attack. Next, objective of the report. First, analyze decision leading to breaches. Second, explore strategy to minimize risk, example email security, Linux system hardening. The last, highlight cybersecurity as an organizational responsibility, not just an IT issue. So the last one, goal. Strengthen IT infrastructure and foster a culture of cybersecurity awareness. The next part is scan threat. So what is scan threat actually? In the context of operating systems, scan threat refer to the process of detecting and identifying potential security risks, vulnerabilities, or malicious activity within the system. This threat may include virus, malware, spyware, and unauthorized access to them, or other harmful activities. So by using threat scanning tools such as Nessus, ClaimAV, and MET and etc., it will help to prevent from malicious activity. So for vulnerability scan, Nessus is a tool that scans operating system to detect vulnerabilities, misconfiguration, and compliance issue. It identifies open port, analyzes service, and compares findings against known threat. Second, malware scan. ClaimAV is an open source antivirus that detects malware, scan file, and chat email attachment for threat. It uses an update virus database and scan either on demand, claim scan, or in real time, ClaimKey. Detected threat can be quarantined or removed. It commonly used on Linux and server for malware protection. And the last one is network scan, NMAT. NMAT is a tool for network scanning and security auditing. It identifies devices, open port, service, and operating system by sending packets and analyzing responses. Admin use it to detect vulnerabilities and secure networks.
Hi, my name is Anis Nadia, and I would like to talk about the hidden cybersecurity vulnerabilities. Cybersecurity issues are often found only after an attack happens, so detecting and fixing them quickly is crucial to protect Linux system. Finding these hidden threats needs regular checks, scanning, and strong security rules. For the next section, I want to highlight common vulnerabilities and their real-world impacts. The first one is misconfigured permission. Linux file and directory permissions are crucial for security. Loose permission like 777 let anyone view or change file and is creating a big risk. This issue often happens due to improper setup, misunderstanding of how permission work. Here's the example. The first example is sensitive configuration file, where a file, as a command you can see, with permission 777 will make it possible for any user to edit secure shell settings, which even a non-administrative user can do. That will lead to unauthorized access, or worse, like weakening the authentication protocols like password. The next hidden cybersecurity vulnerability is open ports access. Linux server can be at risk when unnecessary ports are open or outdated services like Telnet are running. Open ports allow communication but can become security holes if not properly managed. But here's the example. The first one is unused ports. The server was originally set up to use HTTP port active for a website. Later, the administrator switched to HTTPS port 443 for better security but forgot to close port active, which is no longer needed. So the attackers scanned the server using Nmap tools and found port active is open. So they exploit an outdated unpatched vulnerability in the HTTP services that is still running on port active. So this allowed them to take over the server, steal data, or run malicious malware. Next part, I'm going to talk about suggested prevention. Preventing cybersecurity vulnerabilities is the best way to keep a Linux system secure. Issues like weak email security, misconfigured permissions, and open ports can be fixed with the right measures. These steps will strengthen security, reducing the chances of data breaches or unauthorized access. So the first one is preventing misconfigured permissions. Linux permissions ensure that only authorized users can access or change files. Misconfigured settings like overly permissive ones can lead to the security risk. Strong authorization rules help reduce this risk by limiting access or apply permission. So for apply permission by changing the permission on key system file to only allow access by the authorized users. So this is the example commands, where it restricts access to the secure shell configuration file. So the second one is to prevent misconfigured permission is implement access control by using access control list. Further permission can be set to users or group beyond the Linux permission model like this command. So the command is to give a name user read-only access to lock a file. The next suggested prevention is preventing open ports. Proper port management and disabling of outdated services are crucial preventive measures. So for the port management, where it's scanning the system for open ports and closing unnecessary ones, minimize the attack surface. So the example command is, as you can see, this is the command to open port using Nmap, and the second one is the command to block an unused or insecure port like Telnet on port 33.
Next, I will explain about how permissions are assigned to group. Create a group name assignment using sudo group add assignment command. Enter the super user password. We use cat/etc/group to check availability of the group in our computer. Then create a file called project.txt with command touchproject.txt. Assign the file to a group by sudo change group assignment project.txt command. Using ls-l command to check whether project file is in assignment group or not. Next, create two new users into assignment group by typing sudo add user Ali and sudo add user Kamal. Create unique passwords for each of them and enter the user's informations, or just press enter for the default. Then, add the users to the assignment group by typing this command sudo user mod -ag assignment Ali and sudo user mod -ag assignment Kamal. To verify the membership of users in the group assignment, we type groups Ali and groups Kamal. It shows us that Ali and Kamal are part of the users in assignment group. Next, we type command change mode 750 project.txt to change the file permission of assignment group. Lastly, we use cat facl to view access control list for that file. That's all from me. Thank you. I will pass this presentation to the next presenter.
Hi, my name is Amira Husna binti Zainuddin and I will talk about packets filtering. Let me provide you 5 steps to create packets filtering. Step 1 is install and check UFW. Installs the UFW package on your system if it's not already installed. This is the first command to do step 1. Step 2 is configure UFW rules. Add a rule to deny all incoming traffic from the specific IP address and adds a rule to allow incoming TCP traffic on port 22, which is typically used for SSH connections. And this is the command to do step 2. Step 3. Enable and make rules persistent. Activates the firewall and ensures that the configured rules are enforced. The rules will persist across system reboots. This is the command to do step 3. Step 4 is verify the configuration. List current rules and show all the active rules in a detailed format. And this is the command to do step 4. Step 5 is manage and update rules. Removes the rule blocking traffic from the specific IP and resets the firewall to its default state, clearing all custom rules. And this is the command to do step 5. These rules block all traffic from IP and allow SSH connections to port 22.
In this section, we will discuss steps to secure your system by managing incoming packets and defining source address rules. Matching incoming packets. First, identify the source address of incoming packets using the command sudo ufw status verbose. Next, set rules to allow or block traffic. For example, allow trusted systems with sudo ufw allow from 203.0.113.0 to any port 443 proto TCP and block suspicious one with sudo ufw deny from 192.168.1.110. Since we already added the rules for denying from 192.168.1.10, it just skip the adding existing rules. And the next one is set rules based on source addresses. For instance, we allow specific IP with sudo ufw allow from 192.168.1.20. And we can also block entire range if necessary like this. Sudo ufw deny from 192.168.2.0/24. And then we scan for the open ports. Use tool like nmap to identify vulnerabilities. Run a full port scan to check the open ports.
Hi, I am Ain Shafika. I will show you two important UFW commands to manage your firewall, which is setting a default policy to deny incoming connections and auditing your firewall's rules. So first, we're gonna deny incoming connections. First, to block all incoming connections by default, use command sudo ufw default deny incoming. This makes sure no unauthorized connections can get through unless you allow them. Next, we're gonna audit firewall rules. It is important to check and update your firewalls regularly. To view your all existing rules by using sudo ufw status number. This command shows a list of rules with numbers so you can see which connections are allowed or denied. You can easily edit or remove any rule using this number. That's it. So deny incoming connections by default and audit your rules will keep your system secure. In conclusion, protecting Linux system is essential to address vulnerabilities like phishing, misconfigured permissions, and open ports. Key steps include using tools such as Nessus, ClamAV, and Nmap for regular scans, enforcing strict file permissions, and closing unnecessary ports. This is with strengthening network security with firewalls like UFW. Additionally, training staff on Linux environments help reduce human error, creating a stronger, more secure IT infrastructure. By taking these actions, we can significantly enhance system defenses and minimize risks. Thank you.